cover the linked list. In this video, I will just cover only the overview of the linked list. We are not going to do any programming part. Only we have learn what are the basic concept. Next video onwards, I will explain each and every operation of the linked list to the program. By the name linked list means what? List of element. What is the need of linked list? So whenever we are go for the storing the data in the array, main drawback of array we covered, that is it cannot be increase or decrease the size of array. So it is a static, it is not dynamic. Means as per our requirements, we cannot increase or decrease the size. This is the main drawback. To overcome such type of problem, we are going to the linked list. This is the dynamic memory allocation. So a list of element linked together is called as the linked list. By the name linked list means list of element is present and linked together. All the element present in that linked list is called a node, which has two parts. First part, it stores the information and data we want to store. Second part, it will store the address of next node. On that basis, only linked list can be established. And all the nodes are randomly placed. Reason is that it is a dynamic memory allocation. The main problem with the array that if we want to store the data, it should be continuous memory requirement, continuous memory allocation requirements here. Here we can store any number of elements with the dynamic memory allocation. Each and every node stored in the separate memory allocation. So how represent the node of a linked list? Linked list node is consist of two part. First one is the data or information we want to store. Second one is the address of the next node. So simple thing we have to learn right now, how to create a linked list. For example, list of element is given us, that is 10, 20, 30, 40. We want to represent in the linked list. As it is a linked list means each and every node is connected. So if we have information about the starting node, from the starting node we can able to access all the node present inside the linked list. That's why we require a referential variable start. Start is the pointer which points to the starting node of the linked list, and initialization is null because initially there is no element present inside the linked list. That's why it is null. So first node we created, that is with the value 10 as well as the null. So whenever we create the node for the 10 element, we have to store the 10 element and null value. For example, the starting address is 100. How we got the information about the 100? The malloc is the function in C language to allocate the memory on, and it on successful memory allocation means memory is available and it allocate the memory. It will return the starting address of the allocate memory. So starting address of this node is 100. So now, if we store the 100 address to the start reference pointer, then what happened? The start pointer points to the first node, so we store the value. Now the start node points to the first node. So now our linked list is created. Only linked list is created with the one element. Now next element we have to store the value. So we have to create another node and store the value 20, and next pointer is points to the null. So here 200 is the address of the second node. If we store the second node address into the first node, then they are connected to each other. Now we store the 200 address into the first node. Then what happened? The connection is established. So now our linked list of two elements, 10 and 20. Third element we want to insert. So we create the node by help of the malloc function. Malloc function return the starting address, that is 300. Now this address, if we store into the second node, then what happened? Connection established to the third node. Now linked list of three elements. Last elements we want to know. So we create the node, store the data value 40, store the null value. For example, it returns the address value is 400. If we store 400 into the third node, then what happened? Connection established to the newly created node. So now our linked list is created with four elements. We have the starting address in array. So in this case, what happened? If we know the starting address, that is the 100. From 100, we can link all the element present in the linked list on. This is the main thing of the linked list. Only we have to remember the starting address. From the starting address, we can traverse to the all the node present inside the linked list. So next, we have to know what are the different type of linked list is available. There are four types of linked list is available. First category we call single linked list. Second one is the circular linked list. Third one is the double linked list. Fourth one is the double circular linked list. So there are four types of linked list is available. So in and each and every linked list, some of operation we can perform. What are the operation? First operation is the insertion. What is insertion? Insertion means adding an element into the linked list. For example, this is our linked list is already present. Let's take an example. The same example we are consider here. We are already created the linked list. So let's take the linked list is already created with the four elements 10. This is 20. This is 30. This is 40. For example, we are 50. For example, any value we can store. This is the null. This is the. So this is our start pointer. Start pointer points to the first node. So this is our linked list. So insertion means we are going to add an element, add any value into the linked list. So in case of insertion, so first thing is that tree category, inserting at the beginning of the linked list, inserting at end of the linked list, inserting at the specific position. What it means? So first one is the insertion at the beginning of the linked list. So for example, we want to insert 60 into the begin of the linked list. So this is the begin of the linked list. So here we have to create a node, store the value 60, and we have to make the connection. Now here what happened? Now the pointer should be points to start pointer points to the first node. Then only it can be possible. So now start pointer points to this node. So our linked list is created with the insertion in the first position. Second category, insertion in the last position. So 60, 10, 20, 40, 50. Now this is the last position. For example, we want to insert the 80 value in the last position. Here we have to store the 80. This is the norm. Now we have to make a connection. So if we store a node at the end of the linked list, it is called as the insertion at the end of the linked list. Or any position, this is first, second, third, fourth, fifth, sixth. So if we want to insert an any node in a specific position, for example, third position. So first, second, third. So third means in this position we have to create. So in this case, what we have to do? We have to create a node, store the value. For example, 100 we want to store. Then we have to make connection to the third node. Then we have to make the connection. So now the node is insert into the specific position. This is called as the insertion at a specific position. So we cover how to insert in a specific node into any specific position. First we cover insertion at the first node, then we cover insertion in the last position, then specific position. Then next operation is the deletion. So deletion also at begin of the linked list, end of the linked list, and specific of the position. So what it means, we have to understand first. So first we have to insert in delete into first position. Deletion the first. So this element is the first position. So insert in the first position is very simple. We have to simple make the start pointer to the next node and we have to release the memory by help of the free function. So this is the deletion of the node first position. If we want to delete the last position, then what happened? We have to traverse the element, and whenever we reach the element, so before that, this pointer we have to keep the information, and this pointer we have to make the null pointer and release the map. This is the scenario how to delete an element from the end of the linked list. So we cover how to delete the element from the first position as well as how to delete the element from the last position. For example, you have to delete any specific position. This position we want to delete. Then what happened? From this location, if we make the connection this one, from this node, we make a connection to this one. And we have to release the memory by help of the free function. Then we can perform the deletion at any specific node. It can be possible. So we cover all the three category of deletion. Then next operation, traversing. Traversing is nothing. Simple traverse from first node to second node to third node. Remember one thing. Here, whenever we go for any linked list operation, start node is always point to the first node of the linked list. So we never use the start pointer to traversing. We have to create another temp pointer and store the value of start. Then we have to traverse by temp equal to temp next. Temp next. So for example, this is 100, this is 200, this is 300, this is 400. So initially the temp value is 100. So 100 information we get then it is 200, then 300, then 400, then we have to stop. So this is the way we can traverse the linked list. Next operation, searching an element, whether an element is present inside the linked list now or not. So it is simple operation, like we have to traverse all the element present inside the linked list. If it is present, we have to write down the present. If it is not present, we have to write down the element is not present inside the linked list. So whenever we go for any data structure, any type of data structure, we have to know what is the time complexity, means how much time is required to perform its operation. So for insertion in the beginning, at first starting point of it is of order of one. Order of one means it is a one is represent one constant time. So insertion at the end, it is order of n. Why it is n? Because we have to traverse to the n number of elements. For example, in a linked list, 5 element is present. So we have to traverse 5 times. So traversing is required one constant time, means from one node to second node, one constant time second to third node, to third to fourth, so on. So there are n number of required, because if there are n number of nodes, n constant time is required. Insert into the any specific position also, it is order of n. Why? Because we don't know which position. It may be the end position. So we have to go for order of n. Deletion at begin. So deletion is begin is order of 1, because we have to only point to the next node. Deletion at end. So whenever we have to delete a node at the end of the linked list, so we have to traverse to the end position. That's why it is order of n. Deletion at any specific, also same thing, because we don't know which location the element is present. If n number of node is present, so deletion is order of n. So searching an element in the linked list. So searching means we have to traverse all the element present inside the linked list, whether the element present or not. That's why it is required order of n. So where we can use the linked list, means application of the links. We are learning the linked list, but we should know where we have to use the linked list. Image viewer. So whenever we are using any browsing or anything or any screen, one by one image is coming. So how it is possible? Because from one image to another image, it is linked. That's why whenever we press the next button, it will be go to the next. If we press the previous button, it will go to the previous image. So this is the one application, that is the image viewer. Second application, music player. We are a day to day activity, we are music, only music to listen for, to relax our mind. So how it possible? It possible through the one by one songs is linked together. On that basis we can play next music or previous music. Then whenever we are browsing our web pages, so one by one pages is coming. How it's coming? It's also linked together. One by one web pages linked together. That's why we can able to use it. Polynomial operation, we are know how to, what are the polynomial addition of the subtraction, multiplication, division. So in case of polynomial, we store the constant of the polynomial into the linked list. In case of the data, as we know, linked list consists of node stores the two things. First one is the information, and another one is the address. So in case of the information, at part of the information, we are stored the constant of the polynomial, so that we can easily perform the addition, multiplication, or subtraction operation. So sparse matrix is the matrix where maximum elements are non-zero. So we can represent the sparse matrix in a linked list to store the only non-zero value. Stack and queue. So stack is in stack we can perform push and pop operation by using linked list. For queue we can also perform the NQ DQ operation by help of the linked list. Whenever we are using the graph we have to store the information. So in this case, adjacency list we are using to store the information about the node and the information about the edges. Here also we are using the linked list. So what are the advantages of linked list? Dynamic size. First advantage is dynamic size. As per our requirements, we can reserve the memory or we can release the memory. If we don't require, we can release, which is not possible in case of the array. This is the main advantage of the linked list. Second one is the insertion and deletion. If we go for array insertion and deletion, what happened? For insertion, we have to shift all the elements to the right position. And whenever we delete, we have to shift all the elements to the left position, previous position of all the element indexing left position. So shifting is more in case of insertion deletion in a array. But if we go for the linked list, so insertion nothing, we have to only go to that place and we have to perform only the connection of the linked list if in case of the insertion and remove the connection from the node in case of deletion. So insertion deletion is very easy in case of linked list. Time consumption is less, but there are some disadvantages present inside the linked list. For linked list, we require minimum two. One is the data, second one is the address of next node. So storing the next address, that is the pointer, require extra memory for the comparative to the array. So here random access is not present. In case of array, we can randomly access 0 index, 4th index, 5 index, which is very easy. But in case of linked list, we cannot directly move to the fourth in position of a linked list. We have to traverse. This is the main drawback. Here, the linked list is not that much cache friendly because array element is continuously. So, local reference is very easily. But in case of linked list, which is not possible. This is the main drawback of the linked list. So, thanks you for watching my video. In upcoming video, we'll cover each and every operation with the practical implementation in C language. Thank you for watching my video. Please like, share and subscribe the channel. Thank you.